to our today's lesson, where we shall be looking at our next part, which is dispersion and color. And your teacher is still none other than teacher Ahewa William. Now, when the other time we were looking in the previous video, we saw refraction of light, and we saw that when light passes through a prism, it can end up being separated, and that is what we call light dispersion. Now basically light dispersion, like you have that, to disperse is to make things scatter or separate. So light dispersion is basically the separation of white light into its component colors. I know you must be knowing the colors that make up white light, the 7 colors: red, orange, yellow, green, blue, indigo, violet. So if I have white light and allow it to pass through a prism, that white light will be separated into colors as it gets deviated or as it gets refracted. Now what causes this is simply because when this light enters, because it is having different colors have different speeds. Let's look at this prism. As the white light enters, the moment it is being refracted, it will be separated into the different colors. But because red moves faster than orange, and orange moves faster than green, and green moves faster than blue, so red will not be refracted as much as the green, or green will not be refracted as much as the blue. So that's why as it comes out, you realize red will be on top, whereas blue or violet will be at the bottom, meaning this gets refracted more compared to red. So that's how the dispersion comes to happen, or how it takes place. And this dispersion of white light has got some common effects that are very common to us in real life. For example, I don't know if you've ever poured oil on top of water, what you get to see. I think you see something like this. Or if it is a rainy day and you always see what we call the rainbow. That is all, it appears like that. We get to see that is all an effect of scattering of white light. The light that was supposed to be white, it got scattered to produce the colors. Now let's go into detail to see how does now the rainbow get to be formed. Well, we have known it may be scattered, but why does it appear like that? Now when we look at formation of the rainbow, it combines two things. One is there has to be refraction, then another one has to be total internal reflection, and then the scattering. Of course, we know once refraction takes place, the dispersion has occurred. Then total internal reflection is also another issue. Let's look at this. Now, when our light ray meets a drop of rain, the water vapor, or it might be water vapor, because sometimes you may see the rainbow even when it has not rained, but simply because there is water vapor in the sky. So when the ray meets the vapor, the water drop, that water drop acts as a prism. What it will do, it will refract that light. As it refracts it at that first surface, it scatters it. Now it refracts it at a certain angle that it will be totally internally reflected along the other surface. Now as it emerges from another surface, it is again refracted. Now what you end up seeing, for you see here a very beautiful rainbow. And some people believe, okay, well, in the religious part, we believe it was the covenant God made with human beings. You recall the Noah times, the Noah story, and the ark. So as a sign that no more floods. But here in science, for us, we believe it is due to scattering or the dispersion of white light. And because it can be proven in the laboratory that you can produce even a rainbow using a prism, so that's what we believe. And what we know is that it is caused by the droplets of rain. Now the other time, there is a time I was moving and the student was asking me, why is the rainbow curved? Why does it appear in that curve? Now, that one I will explain it in the simplest way possible. For you to see that rainbow, it has to be, the light has to be refracted at a certain angle, and that angle is around approximately 42 degrees. Now it means for every ray that will be refracted at that angle and it enters your eye, it will produce the colors of the rainbow. But the trick is, for you to maintain that angle, you'll end up describing a circle. I want you to think about it like if you're to maintain the same angle but looking at different parts, you realize that it will be like a bicycle. If you've ever seen a bicycle wheel and the bicycle spokes, how they are tied from that wheel, they are almost at equal angles to the center. They are meeting the center of the wheel at equal angles, or what we call the axle, at equal angles. So it's like it describes a circle. So the same applies here to the rays. The rays are acting as the bicycle spokes. So if they are to meet you at the same angle, they'll end up forming a circle. Now that's why the rainbow, the colors you'll be seeing, they'll be curving to form a circle, because they have to maintain that angle. And in actual sense, the rainbow is supposed to be a perfect circle. Only that, because there is earth, the earth, as if it covers you, you'll not see the other part of the rainbow, but it is supposed to be a perfect circle. So that's about dispersion of white light and what it can cause. Now we have seen that when dispersion takes place, it gives rise to colors. Now we shall talk briefly about why do objects appear colored. Because when you look around you, you'll see white, green, yellow, orange. You'll see a brown, a black person. But why do objects appear colored? Objects, simply, what happens is when light falls on an object, part of that light will be absorbed, part of that light will be reflected. Now, bodies have a tendency, they will always, whether it is a human being, whether it is a leaf, whether it is a cup or a what, it will absorb the light. All other lights of any other wavelength, it will only release the light which is of its own color. That is what it will be able to reflect. Now, it means that the object can be, if it is green, it will absorb all other colors and it will only reflect the green color. And since we know that colors, what differentiates colors is just their wavelength. A given color is of a given wavelength, and that color which will be reflected is what you will see as the color of the object. If you see an object appearing red, it means that object is reflecting red. It is absorbing other colors. If you see an object appearing blue, it means that object appears, it has reflected blue color. Now we have categories of colors. Some of them we call them primary, others secondary. The primary, they include the red, the green, the blue, or the RGB. This is the primary. Why are they called primary? These are the foundations of all other colors. They come from these three colors: red, green, and blue. When we combine all of them, they should give us white. When we mix any of them, we can start creating other colors, like the ones we call the secondary. Secondary colors, we have yellow, orange, indigo, violet, etc. We have even the ones we call the tertiary, other colors. But for this video, I will restrict myself to these. And maybe to put it more into context, I can show you some color mixing. That if we have our primary colors, we can mix them. You see we have red, we have green, we have blue. When you mix red and blue, we form what you may call light blue or cyan. When you mix green and red, you form what you call yellow. When you mix red and blue, you form magenta or indigo, in other words, and many others. We can continue mixing these colors, but you see where all the three colors are meeting, we are getting a white there. So white is composed of these three, but also other colors that can be formed, because your eye can mix them. Even when you've not mixed them, the eye can mix them and you'll start seeing those colors. Let's look at this wheel here. We see we have primary colors. When we mix any two primary color, we get a secondary color. When you mix a secondary color with another primary color, we get what we call a tertiary color. For example, you mixed red and yellow, you get orange, or red and yellow, you get orange. You mix, let's say, sorry, this was supposed to be green, sorry, it is mixed up here. You mix green and let's say yellow, you get something either dark green or light green, blue and green, like that. You get different colors. It all comes out of the mixing. Now, like I had already told you that appearance of the objects, objects appear the way they appear simply because of the colors they reflect. For example, we can look at these objects. If I have a white surface, it will reflect all the colors. If the color entering, that is a visible white light, meaning it is having all the 7 colors to reflect all of them, meaning what you see will be all the colors coming to your eye, meaning when they all come, it will be white. If it is a red, then it will absorb all the other colors. It will only reflect red. That's why it will be appearing red. If it is a black surface, meaning it will absorb all the colors, it will reflect no color. And that's why it will be black, because you're not seeing any color coming from it. Whereas for green, it will absorb all the colors and reflect only green and many others. So that's why when you see a blue or red or green or indigo or yellow, know that object is reflecting that particular color of light. We have what we call the color filters. Now, color filters, for them, what they do is they allow light. Like you hear the word filtering. When you're filtering, you're allowing something to go through. For them, they allow light to go through. Now, but they also behave like bodies. They will only allow a color of its own to pass through. You see? It is like a sheet. It may be a piece of paper. Many of you have ever seen stencils. That is an example of a filter. If it is green, you realize it will only allow green light to go through. If it is blue, it allows only blue light to go through. And we have we can look at this scenario. For example, if I have a red filter, it will absorb all other colors falling on it, and it will only allow red to go through. If it is blue, it will absorb all other colors falling on it. It will allow only blue to go through. If it is green, same thing. So you end up having those colors, or sometimes you may be seeing like, that's why when you go, let's say you put a certain piece of paper in front of light, or maybe you go in, let's say a disco lights, they may strike your cloth and then it appears a different color. Now that brings in color mixing, where you have secondary color filters. Like let's say if you have a green color, this is primary, blue is primary. Let's talk about yellow. Now we know how do we get yellow. We said you can get yellow depending if you mix red with some, if you mix like let's say green with orange, and you can end up having a yellow because you're diluting orange. Now this yellow, it means which colors are coming out. It will allow white light to come out, yellow light to come out. But yellow light is composed of what? It is composed of the other colors, you see, green and red. Now those colors, they will be the primary colors coming out, but for you will be seeing them as yellow. It will only allow the colors which belong to it to go through. Other colors will not be allowed to go through. If it is magenta, which colors will it be allowing? You can guess. Blue and red. So it will be allowing blue and red to go through. So you'll be seeing it as magenta. So that's how filters work. Even when you see a person is at let's say in a disco light, the cloth is appearing a different color, it is using the color mixing concept. So with that is what we wanted to talk about today, about colors. And we have seen how colors come about. It is due to separation of white light, and we've seen that separation of white light can end up causing objects now to start appearing the different way, because they will absorb other colors and reflect only the color of their own. Then you are able to see them in the original color. We have filters which can help us produce specific lights. If I want a green light and I have white light with me. I can just use a green filter to allow only green light to go through. With that, allow me end there until we meet in another video. I wish you a blessed day or night, depending where you're watching the video from. Bye bye.